In Algebra 1, Section 5.3, we're dealing with another method besides substitution. And remember, because substitution works best if you can find a variable that has 1 as its coefficient. But if it doesn't, you can use elimination. But the great thing about elimination is even if it does, you can always still use it. It applies to everything. So what you're going to do is you're going to first align the terms, because sometimes, for example, this one is not so lucky because sometimes you have to rearrange an equation, but the x's have to line up, the y's have to line up, and the constants have to line up on the other side of the equal sign. Once I put it in that format, okay, like terms align, I'm going to eliminate one variable and solve for the other. And I can eliminate by adding or subtracting them together, okay? If it confuses you, pick one. But what I'm trying to do by eliminating is getting a 0. So for example, if I add these together, this would be 2 plus 2 plus, y, negative 5, whatever it may be. None of these would be eliminated. But if I subtracted, right, 2 minus 2 is 0. And because it's 0, this cancels out. I've then eliminated one of the variables. Now I'm going to solve for this variable. So now that I eliminated an x, I'm going to solve for y. But I have to finish what I started. I can't just take that and cross it out. What am I going to do with these? I'm going to finish. I have to then subtract this. So positive 1 minus 5 gives me a negative 4y equals negative 5. Oh, sorry. It's positive 1 minus a negative 5. Because if I was adding, then I would be positive 1 plus negative 5. But this is positive 1 minus a negative 5. And minus a negative is positive. So this is like saying 1 minus negative 5. So this would equal 1 plus 5, giving me 6. So this would be 6y. And then negative 5 minus a negative 13. So negative 5 on the timeline goes more down to negative 13. So this would be negative 18, right? Then I can solve for this other variable. Divide by 6, y equals negative 18 divided by 6, which is negative 3. So I have a y. Once I have that y, then I do the same second half as I do with substitution. I'm going to take my one variable. Now I don't need substitution or elimination or anything like that, because then I can plug it in and I have one variable and that's it. I'm going to do it to an original equation. Don't do it to one of these, do it to an original equation. So I'm going to I'm going to pick the top one. So 2x plus y, 1y, which is my negative 3, equals negative 5. So I'm going to add 3 to both sides. This gives me 2x equals negative 2, x equals 1. So I have my x, and I have my y. My x is 1. Nope, sorry, it's negative 1. Negative 2 divided by 2 is negative 1. So this is negative 1, and my y is negative 3. And I put it into point form one more time because this is the point that if I graph these two equations, they would intersect. And if I plug this in mathematically, it should make both equations true. It is the solution. So let's try the next one. Sorry, my caps are. So I'm going to take these and I'm going to align them. I'm going to put this right here, negative 3x plus y equals negative 5. All right, these are aligned. But this time, unlike this one, I can't just subtract. There's no way I can eliminate it. So this part might be a little bit more trickier, but I can do anything I want to these equations as long as what I do to one side, I do to the other. Do you remember that? I can balance, when I'm trying to solve for this, I can do anything I want. I just have to make sure to balance it by doing, if I do to one side, I have to do to the other. For example, if I turn this bottom one into a 2y and subtract it, then I should be able to eliminate. Well, how do I do that? Well, I'm going to take this and I'm going to multiply it by 2. everything because I have to multiply this whole side by 2 and I have to multiply this by 2. And every term I'm going to share. And a term is either separated by a plus, a minus, or an equal sign. So I'm going to take this 2 and multiply it by this whole thing, negative 6x, and then multiply it by this whole thing, so plus 2y, and then I'm going to multiply it by this whole thing, which is equals negative 10. I've kept the balance. The equation is still equal. It's just now I have a 2y and I have a 2y. So if I write it, use black. So if I write the original equation, x plus 2y equals 11, and I write this new equation, negative 6x plus 2y equals negative 10, they now line up. And if I subtract this, and I'm going to put it in parentheses because this is already a negative, so I have to be careful. If I subtract it, positive 2 minus a positive 2 cancels out, right? A 1 minus a negative is the 1 plus 1 plus 6. 1 minus a negative 6 is the same thing as 1 plus 6. So I end up with 7x. And then 1 minus a negative 10, 1 minus a negative 10 is the same thing as 1 plus 10, which is 11, divide by 7. Oh, here are fractions again. And I end up with x equals 11 over 7. Okay, that's my first one. Remember, I don't just look for one, I need to look for the other. So once I have this, I'm going to plug it in. The question is, which one can I plug it in? I can plug it to either of the original equations, either this one or this one. I'm going to plug it into this one because it looks a little easier. So 11 over 7 plus 2y equals 11, right? This is the one I'm trying right here. Okay, so what I'm going to do, what am I going to do? You know what? I really don't like this fraction. So what I'm going to do is I'm going to multiply the whole thing by 7. And I can do that just because I can, again, I can do it because I'm doing it to both sides. So if I do 7 times 11 over 7, it's 77. And the reason why I do that is this 77 over 7 is 11. It cancels out, okay? So this 7 and this 7 cancel out, leaving me with just 11, okay? And I have to do here, I have to do it to everything, so plus 14y, and then equals 77. Now this is a little more doable for me. If you like fractions, that's fine, because the other method would put it all into common denominators. So whichever one you prefer, it doesn't matter. I'm going to minus 11 from both sides. I end up with 14y equals 66, and y equals 66 over 14, which can be at least 33 over y equals 33 over 7. Okay? So my equation, I know the feeling sometimes that I feel like I get it wrong because it's in fractions, but that's how it is. My x is 11 over 7, and my y is 33 over 7. You can put that in mixed fractions if you want. I'm just leaving it in improper fraction, either one. So, go ahead and write this down. Remember, elimination works for all terms. I just have to, it's a more work than substitution, but substitution, again, has that one requirement. It's up to you. The next section, you're going to have to choose between the methods. You have 3 graphing, elimination, and substitution to choose from. So go ahead and write this down and try page 347, numbers 5 and 8. 347, numbers 5 and 8. I will see you in class.